Algebra students, we've talked about how to factor by looking for a greatest common factor. We've talked about how to factor with grouping, which I don't love, but it does have its potential use in this next unit. And then we've talked about factoring quadratic trinomials that look like this. Notice the number here has always been 1. Today we're going to talk about what happens when there's an actual number here. So I'll put a letter there called A. So this is called the standard quadratic, ax squared plus bx plus c. And sometimes the standard quadratic trinomial factors. And let's look at some examples and see how we figure out how they factor. Alright, so the way you're going to do this problem, well, there's actually multiple ways I'm going to show you right now. The first way is to start with 3 and write it as 1 and 3. And then with 7, think about the factors of 7 as 1 and 7. Now what you're going to do is you're going to try every combination. So 1 times 7 is 7. And I'll use a different color here. 3 times 1 is 3. And then the other option is 1 times 1 is 1. And the other option is 3 times 7 is 21. Once you get these numbers, 7, 3, 1, and 21, you're going to add, because this is a positive sign, you're going to add these numbers looking for the middle number. So when I add 1 and 21, I don't get 10. But when I add 7 and 3, I do. So how are we going to use the fact that 7 and 3 add to 10, 1 and 3 multiply to 3, 1 and 7 multiply to 7, and now we know this factors, but how do we write the factors? Well, it starts by how did you produce the 7? You produce the 7 by taking 1 from the left times 7 on the right. So the numbers on the left are the numbers that go first. We have a 1k and a 3k. That first product, 1k times 3k, is what's going to give us 3k squared. That's why these two numbers go in the first position. Now the 1 has to multiply a 7, so this one has to multiply a 7. So I know the 7 goes here. That forces this number to go here as a 1 because I need to take 1 times 3 and I need 1 times 7 at the end. So when you multiply all that out, you get a 3k squared, a 7k, a 3k, and a 7. And that 7k and 3k are what combine to get you a 10k. Now because this first number is negative and the constant is positive, the signs are plus plus or minus minus, and in this case it's minus minus. So your final answer is k minus 1 times 3k minus 7. Good? Alright, that's one way to do it. That's the way I typically do it because I practice this a lot. Another method with this same problem is to take 3 times 7, which is 21, list the factors of 21, find the factors in 21 that add to 10, and then rewrite this polynomial as 3k squared and use these two numbers to do what's called splitting the middle term. So instead of saying negative 10k, I'm going to put this middle term as a minus 3k and a minus 7k. Now your job is to group these first two terms together and group these second terms together. When you group the first two terms together, you can take out a 3k and you're left with a k minus 1. When you group these second terms together, you want to take out a negative 7, and you're left with a k minus 1. And now what we have is this common factor of k minus 1. This is that factor by grouping method. And it will work when you split the middle term. And that's the exact same answer I got before. So 2 ways to solve these, to factor these. Let's try another example. So if you want to pause the video and try this on your own and see how you do, great. So I'm going to list the factors of 2. I'm going to list the factors of 30. Because I have a minus sign, I'm now going to look for how do factors of 2 combine with factors of 30 to have a difference of 7. Now I've done this a lot, and I look and I look and I play with this, and I'm looking for a difference of 7, and I get 20 and 3. I get, oh, there they are. I found them. So 2 times 6 is 12. 1 times 5 is 5. 12 and 5 have a difference of 7. So I in my head did all this. 1, 60, 2, 30. 2, 30, and then 4 and 15. 6 and 10, as well as 3 and 20. And then the last combination, 10 and 6, and the which I've already listed, and the other combination would be 12 and 5. So that's the combination that works. Notice that those are all factors of 60, taking 2 times 3. So now that I've got them that I know which give me a difference, I'm going to put a 2R and an R in the first positions. These two numbers always tell me what goes first. 2R and 1R. I need the 2 to multiply a 6. So the 6 goes here. That forces the 5 to go there. Because this is a minus and this is a plus, I need one of each sign. How am I going to produce a positive 7? I need a positive 12 and a negative 5. The only way to make this a positive 12 is to put a plus sign here, and the only way to make this a negative 5 is to put a minus sign here. Now, if you like the other method of splitting the middle term, you take 2 times 3, which is 60. You find the factors of 60 that subtract to 5. You write the problem 2r squared minus 5r plus 12r minus 30. You group these terms together, and you look for the common factor. In the first 2 terms, the common factor is an r. In the second 2 terms, the common factor is a 6. When you take out the common factor of r here, you're left with 2r minus 5. When you take out the common factor of 6, you're left with 2r minus 5. Now take out the 2r minus 5, and you're left with r plus 6. And that's the exact same thing I got over here. We got a couple more examples coming up. Try this example on your own. So I'm actually going to start doing a combination of the 2 methods. 5 times 8 is 40. The factors of 40 are 1 and 40, 2 and 20, 3 no, 4 and 10, 5 and 8, 6 no, 7 no, 8 I've already listed. Now I'm going to find the factors of 40 that add to 14, 4 and 10. How could I produce a 4 and a 10? Well, with 5, it's 1 and 5. With 8, it's 1 and 8, and it's 2 and 4. The best way to get a 4 and a 10 is 1 times 4 is 4. 5 times 2 is 10. So that means x and 5x, because the numbers on the left here are always your first numbers on the left in the parentheses. The 2 and 4. 2 has to multiply the 5. 1 has to multiply the 4. Now the signs, because this is plus, go minus minus because that second term is negative. The other method, once you get the 4 and 10, you write it as 5x squared minus 4x minus 10x plus 8. Now, why did I know to put minus 4x and minus 10x? Because I have to add those terms to get a negative 14, so I need two negatives. Now, another way is maybe Diego wrote 5x squared minus 10x minus 4x plus 8. Watch this. It doesn't matter which way you write it. If I write it this way in red, I take out the common factor, I take out the common factor of x from the first two terms, and I'm left with 5x minus 4. I take out the common factor of negative 2 with the second two terms, and I'm left with 5x minus 4. Now I take out the factor of 5x minus 4, and I'm left with the factor of x minus 2. If I had written it this way, like maybe say Mac wrote it this way, now I take the common factor of 5x out here, and I'm left with x minus 2. Here I take out the common factor of negative 4, and I get x minus 2. And now the common factor was x minus 2, which I take out, and I'm left with a 5x minus 4. And all three of these say the exact same thing with multiplication, because a number times a number doesn't matter if you switch the order. Let's try another example. So again, take 5 times 20 and you get 100. Factors of 100 that add to 52. Well, that's 2 and 50. So how could I get a 2 and 50 using the factors of 20 and the factors of 5? Well, 5 times 10 is 50 and 1 times 2 is 2. So again, the numbers on the left would be a 1p and a 5p. The numbers on the right would be a 2 and 10, but I have to put the 10 over here so it multiplies the 5. That forces the 2 here. Then when you figure out the signs, this is a plus, this is a minus, so it's minus minus. The other way is split the middle term. 5p squared minus 2p minus 50p plus 20. Here, take out the common factor of p, be left with 5p minus 2. Here, take out a negative 10 and be left with a 5p minus 2. Now take out the 5p minus 2 factor and you're left with p minus 10. Good? I don't believe this is an easy process. I think this becomes easy with practice, but I think it is hard. We are factoring quadratic trinomials where the leading coefficient, the first number, is not 1. That is a difficult process. If I were you, I would watch this video one more time. I would watch it maybe 2 more times because you're watching it at double speed anyway, so it's about 15 minutes long. If you watch it at double speed 3 times, you're looking at 22 minutes. Practice these problems as you watch it a second time. Know that I will only put a few of these on your next test on Tuesday, the 17th. So I'll only put 1 or 2 of these because the other factoring skills are more important. But I still want you to be able to do this, and we will keep working on this for a while. This becomes easy with practice. So practice, practice, practice. All right. Have a good night. Peace.